I make a show for screen. Okay, session today talk about four pumps. When we're going to discuss pumps. Firstly, pumps classified in two categories: dynamic pump and displacement pump. These are the two main categories for the pumps. For the first one, for dynamic pump, have some specs and some advantage and disadvantage. Also displacement pump theme. Starting by some different main points between these two. Okay. Firstly, for dynamic pump, I will focus for the important units and going the lowest important at the end. Important units for classification between these two, and this question theoretical a lot coming in the exam. For dynamic pump, it is used for high discharge and low head. High discharge and low head. Again, dynamic pumps is used to high discharge and low head. But for displacement pump, used for high head and low discharge. High head and low discharge. This main point for classification for these two. What else? Importance also in the exam for theoretical coming many. Priming. Priming problem. For dynamic pumps, we have a problem of priming. We face a problem for priming. And there should be care for this one to avoid cavitation or anything. But for displacement pump, there is no problem for priming. What's priming actually? Priming, it is filling the pump before you start operation. Okay, just filling the impeller and the pump from the suction to the discharge to be sure this is totally liquid. Okay, this is the priming. For displacement, no need for priming process. Also for dynamic, it is low costly and lighter for the weight. Efficiency, it is low compared to displacement. Normally the fluid used is low viscous fluid. So one of the famous application is domestic pumps, domestic water pumps. Okay, domestic water pumps or domestic application in general. But for displacement, it is higher efficiency compared to dynamic. It is costly, heavier, normally used for industrial application, and regularly use high viscous fluid in these pumps. What is the types for these pumps? Dynamic, like centrifugal pump, one of the famous pump, and also other one is axial pump. Centrifugal pump like radial pumps, mixed pumps like vertical or horizontal. This is the famous design for the centrifugal pump. Input flow, inflow all the time from the center for the pump, and sometimes we mention for this is I diameter. I diameter is input diameter, I diameter. Okay, this is the impeller actual, and this is the casing for the pump is called volute, and this is the outlet. Outlet may be a horizontal outlet, maybe vertical outlet. Okay. Displacement pumps, this classified in two parts, reciprocating and rotary. Reciprocating pump, it is piston, like diaphragm also. And for piston, we have one piston, two piston, okay. Used normally two piston to avoid and solve the problem for fluctuation, because when you use one piston, we have a fluctuated flow, okay, pulsating flow. But centrifugal, for example, is continuous flow. Rotary pumps like gear pumps, loops, screw, like vane, all these types for rotary pumps. Okay. You have one file here. I sent you by WhatsApp. This file, PDF file. Where is it? Yes, I get it. I'll make sure first. Share, share, share. Okay. This file, this is a good summary for pumps actually. I found it and I found many information important for pumps. I will check with you quickly. This notes, it is not huge. I think around 30 pages or less for the important information. Each information just a half page, something like this for each note. It's good reference for pumps. Check with me. As you see here, still now we don't reach to the first page actually. For the yeah, we are near now. 10 pages. It's not important. Just information for starting. What we will see. What we will show inside. Yes, first page is 12 actually. Centrifugal pumps. He talked about for the beginning here centrifugal pumps, and he mentioned for some notes about for everything here like impeller, volute, diffuser, braking, and so on. Here talk about for the volute here also. Okay. Okay, going to the details. Here, firstly, this centrifugal pump design. This is the impeller. This is the eye impeller. This is the suction. This discharge, maybe like this vertical or sometimes horizontal. This casing is called volute. The definition of casing is important. Here we mention for the single volute. Here saying double volute. Small information. This diffusers. Just to guide the flow and then make excavation for the flow. This diffuser. Impeller classify as a suction types, single suction, for example, double suction is the shape for that. Also, we can mention it is open impeller or semi-open or closed impeller according to the design also. Classification according to the flow direction. We classify as a radial flow pumps. This is the radial flow pumps, radial. Okay. And we have axial flow, this axial, and third one mixing between these two. Multi-stage centrifugal pump, I will show also this to you, this multi-stage centrifugal pump. The main objective for multi-stage centrifugal pump to obtain what? Actually, the pump is the main function for the centrifugal pump is high discharge and low head. So the main function for the multi-stage centrifugal pump, like series pumps, okay, we don't obtain more discharge. Actually, the flow is the same. We as continuity equation, N equal out. So the main function for multi-stage centrifugal pumps is increase the pressure, obtain high pressure, because there is no effect for the discharge itself. Important notes here for the component. Yes, net positive suction. Cavitation first, we discussed cavitation and what happened for during cavitation when we study the vapor pressure in the first session. And we need to avoid this cavitation. It means we need to avoid to reach the pressure at the outlet side, because normally the pressure at the outlet side, at suction side, is decreased. But we need to avoid to decrease to reach locally to start to boil. It reached locally to vapor pressure to don't start to boil. This is the main idea for that, to avoid cavitation. Net positive suction head, this actually calculated the net positive suction head to be sure this pump is far and not reach to the vapor pressure to start boiling or vaporizing. So we don't going to have a cavitation problem in the future. Okay. So we calculate net positive suction head. The main equation for net positive suction head is a difference between suction pressure and saturation pressure. Actually, the equation used at the end for the numerical part, it is not this equation at all. We have extended to other parameters I will show with you, because it's coming many times this question for numerical part. But also it's coming as a theoretical. I have some sample theoretical related for net positive suction head. We will show together in the presentation. But be know for that, this definition, net positive suction head is equal to pressure at the suction, pressure of suction, minus the pressure of the saturation. Sometimes we mention for saturation pressure, vapor pressure. Normally we use vapor pressure. Means suction pressure minus vapor pressure, it is net positive suction head. Okay. If you need to go in details, we're going to this equation. Net positive suction head is equal to VA, which is B atmospheric pressure on the center of the liquid for the tank source. BST, it is a pressure static. Pressure static, it is actually the pressure effect on from the level of the tank to the inlet section of the pump. So we measure this pressure as a static. We measure from center of the pipe of the suction, center of the suction pipe, to the limit or the elevation or altitude for the tank or reservoir, the source of the water. Okay, pressure due to elevation between liquid surface and pump suction. HF is related to losses, head losses up to suction part, up to suction, not total head losses, up to suction. B sat is B saturation, which is referred to vapor pressure, and this is a property for the material, but at a certain condition should be mentioned for the temperature and the given in the problem B saturation. Okay, normally B saturation is given in the problem. Is coming a lot for this equation to apply this equation in the exam. B saturation given direct, B atmospheric given direct. Maybe you need to change it the unit, something like this, or you multiply gamma to change it from head form to pressure form, or from pressure form to head form, because this equation is same as the equation of head form. This equation is similar exactly to, why it is not to right, please, right. Why don't write? Okay, I write H atmospheric, H static, H losses, H saturation. Okay, this all in head form, because this one, if it is in head form, should be also represent to head. Okay, head, not pressure like this, to be equivalent, because this plus, minus, and so on should be always equivalent.
So this equation is not in correct order, or
again?
The net pump head is not
Yeah,
in correct
because
order.
given pressure, no problem. Maybe it is missing from the writer itself, no problem. But should be all the same unit. And the default is measured by units of head. Why is this the default? Because actually this one net positive suction head. So we solve this problem regularly by default by head form. So this pressure atmospheric should be by head, static by head, losses by head, and saturation by head. Normally saturation is given. Maybe you need to change anything small. Atmospheric part is given. At the end, the remaining static and losses. Normally static we can measure from the figure given in the exam. Just going to measure this according to the definition for what is represent static pressure. And last one, H losses. This H losses, HF. For H losses, this takes some time. Why? Because this H losses is not coming direct. It's given some information and values related for the parameter for H losses to calculate it. It's not small equation. We will study today also for this. So we're going to continue here. Okay. How to prevent cavitation. Characteristic curve for centrifugal pump. This characteristic curve. How to make shut off head. It's measured when this point is 0. And bomb run out.
Just 1 second.
There is some information for summary. After summary, I think going to the next page for positive displacement pump. And here represent some information about for different type of pumps like reciprocating pump, gear, screw, loop, vane, diaphragm, different types of pumps. Just read it or know what is the symbol type for each one. At the beginning here, start by the principle of the displacement pumps like this piston and move stroke and discharge, suction stroke and discharge stroke, and so on. What happened during these strokes? Okay, and then going to the types. Okay, very simple PDF file, not huge. Rotary pumps, for example, gear pumps. Okay, it's a good guide for the pumps. If you need to read to collect more information for pumps to make refreshment for this pump. Okay, going back to the slide. Selection of pumps. Selection of pumps. Normally, we have two famous curves used for selection of pumps. But before we talk about for those curves represented in the diagram, actually, what is the main two parameter to select a pump? What is the two main parameter to select a pump? It's coming a lot in the exam. And very easy.
Pressure and capacity.
Pressure and
Total percent flow rate.
Pressure and flow rate. All is agreed. All is accepted. Okay. The two curves if you know these two curves, you can select a pump. Is important for selection of pumps is pump curve, and the other one is system curve. For both these two, we can going to decide for selection of pumps. Okay. This parallel pumping, for example, what happened for parallel pumping? This single pump, the first curve is this one, single pump. And if you check the point here for this one, we will found this distance is x. And if we're going to another point for another selection, we found this y. Oh, but when we're going to use parallel bump curve, parallel bump curve, bump and the bump and the bump, but this bump is in parallel. Okay, what happened? We will find the flow will be double, discharge will be double, okay, at constant pressure. Also, if we change the point selection, we will find the same answer here. This first one is after barrel pump, we added another one, but we'll see another extension for the flow rate. Because for parallel flow, if these two pumps is the same equivalent, so first one take it Q1, second one take it Q2. At the end, what we obtain Q1 and the Q2, Q1 plus Q2. So for the main line, before you distribute into two, we have this one plus this one. Here, I will show you. Here, for parallel, it's coming like this. You know the circuit for electric? This pump 1 and pump 2. So Q1 here, Q2 here. Means at the end, you will find the Q1 plus Q2. And sorry. And also here, at the beginning, Q1 plus Q2. But inside going to this one separate and this another one separate. But at the end, we obtain the same Q according to continuity. Okay. Affinity law. One of the equation also is coming many times in the exam, a lot in the exam. Sometimes is coming for a pumps problem. Sometimes is coming for fans problem. Okay, according to the application. But to easier to save, this equation at the beginning is important than this one. The relation to diameter is not important like the relation to the speed, okay, n. But it's no problem if you know or remember one, but second one is the same, not different, it's typical. We here study the change of the speed n2 by n1 with flow rates. With what? With flow rates. What is this flow rates? Q2, Q1. Also probability with pressure, B2, B1. Last with power, B2, B1. We will see here for the discharge into by N1 is equal to what? If you check this one here, Q2 by Q1, N2 by N1 equal Q2 by Q1. And if we study this one as a function with pressure, we will find B2 by B1 past squared. If we're going to last relation, we'll find power 2 by power 1 to power 3. Means all the same, but one with no power, second for the pressure, power 2, third for the power with power 3. You see the screen? Clear screen?
Yes, yes.
Okay. Any questions for affinity law?
No.
No questions for all? Okay. Ready for questions? Answer, please.
A. Axial flow.
All agree?
D.
Again, all agree?
A. Axial flow.
A. Axial flow. This is a higher specific speed. And also to be aware, specific speed is equal n multiply square q divided by h to power 0.75. Also, this is the order for higher to lower, axial, then mixed, then radial. Answer, please.
Kinetic and
D.
D.
D. प्रश्न जी काहींना जे होत.
D.
Final. Actually, pressure energy, kinetic energy, or both. Next,
Centrifugal.
C. Centrifugal pump.
B.
yes, correct. Next,
C. Single stage and horizontal shaft.
all agree? Or no one still
Yes.
no idea?
B.
Single stage and horizontal. Next,
C. Centrifugal pumps.
centrifugal pump.
B.
Correct. Next,
D. All of the above.
All.
all is types of rotary, correct.
Yes.
Next,
Centrifugal.
which one?
Centrifugal. C.
Centrifugal.
Correct. Next,
B. Lower.
Yes.
Higher than that of centrifugal.
Lower. High head. Lower.
Higher. A.
lower. This is what I start for
Yes.
centrifugal, higher discharge, low head.
Go ahead.
Displacement, high head, low
But
discharge.
no to search.
Important is this information, please. Next,
A. Reciprocating pump.
Centrifugal.
A.
reciprocating bump. Next,
C. Priming.
Priming.
C.
correct.
D. 735.
735 watts.
Final,
Yes. D.
correct. Next.
It's E, both A and B.
A and B.
A and B.
Correct.
High
B
discharge.
high head.
A.
B
High
High head.
discharge.
Which one?
A.
D,
High
D.
discharge.
B high head.
high head and high discharge.
High head.
Head.
Only. Multistage centrifugal pump.
Yeah,
The
the
main function
head
is
is low. The head is low in
actually,
centrifugal.
yes, actually it's high discharge and the continuity equation, there is no change in discharge. But what we obtain? High
Head.
head.
Excuse me, sir.
Yes.
For
C at the
the
center.
previous question,
Mhm.
if we, question number 13, this one. If we need only high head, we will be using reciprocating pump, right? So when we need high head and high discharge, we are using multi-stage centrifugal pumps, right?
For multi-stage centrifugal pump,
Yeah.
we use it to high head. Why? I discussed this for the PDF file.
Yeah, that's right.
Yeah, because centrifugal
So-
pump is normally give high discharge.
Yeah.
And multi-stage, there is no effect in discharge. What we consumed in the beginning for the for regular one is the same here for multi-stage. The same Q going in is the same going out. No change in flow rate. But what we obtain as advantage, head is increased. Head is increased.
Okay.
C at the center.
Yeah, excellent. This casing. This casing, not casting. Casing.
Yeah,
Cavitation.
cavitation.
Correct. Sorry. He talk about for casing of centrifugal pump is designed so as to minimize
Yeah, it converts mechanical to kinetic. So
the main function for centrifugal pump actually obtain high kinetic energy.
yes,
This is the main function to obtain high discharge. So the main objective for this, what is the main objective? Losses of kinetic energy. To avoid any losses. To select a pump, you look at
Delivered flow and pressure.
yes. Fluid coming into the centrifugal pump is accelerated by
impeller.
Impeller.
Centrifugal pumps transport fluid by converting
Mechanical to kinetic.
Mechanical to hydrodynamic energy.
Kinetic energy.
very tricky these questions.
D.
Final
C.
kinetic energy to hydrodynamic energy. Kinetic energy to hydrodynamic energy.
Very confusing.
Which questions?
Centrifugal. No.
This one?
No, correct. Got it. Next.
No problem?
No problem.
Okay. Centrifugal pumps transport
Fluid.
Fluid.
fluid. Which among the following controls the flow rate?
A valve.
A valve.
Valve.
Transfer energy from
Yes.
rotor to fluid.
A.
Rotor
A.
to fluid. Yes. Main function of centrifugal pump are to
Transfer position.
Transfer energy.
Transfer energy.
D.
D.
yes, transfer energy, correct. Turbo machines work under
Third law.
First law.
actually second law. Second net. What is centrifugal pump?
Machinery. Turbo machinery.
Yes.
Concur.
Answer?
Pump
Ready.
Clear, yeah?
curve.
Yeah.
Flow rate.
Fluoride.
Fluoride.
Right?
A. Yes. One section is used for resistance. Cavitation. Priming.
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 Analysis to what? Cavitation.
Cavitation. Midpoint section है.
Mainly the main function to be aware we're going to has the cavitation happen or not. Next.
Section and this
Section.
saturation.
Section and
Section.
suction
Yes.
and vapor
A,
pressure.
A.
Vapor pressure.
Excellent.
Net
Answer?
point section.
Net positive suction head.
Net
Section.
positive suction.
Section head. B.
B.
Positive displacement.
B.
Displacement.
Yes. Thanks. Next.
B. Number of cylinders.
Reciprocating. Yeah. B.
Yes.
Number of cylinder.
Which one?
D.
A. Lube oils.
Yes. Correct.
Device.
Positive displacement.
Positive displacement.
Positive displacement.
It decreases.
I will write to the equation.
Increases.
A. Expansion.
This is general equation for inefficiency. And in this case, what is the output coming from the flow? Correct? Means gamma QH. This is the power divided by input power coming from the motor. Correct or not? So increasing flow rate, what happened?
Efficiency increase.
Answer?
Increases.
decreases. Why? This in numerator, when flow rate going up, what happened for efficiency?
Increase.
I know you see the answer, but I need discussion. What's the difference?
Okay.
Manometric head.
Yeah, you talk about for difference, it means manometric is measured that.
In total, yeah.
Meter.
Answer?
Meter. A.
Meter.
Meters.
Answer?
A. Pump hydraulic efficiency.
A manometric head.
A.
Pump hydraulic efficiency.
A
Decrease.
meter.
Decrease. Decrease.
Is
Decrease.
Increase, decrease.
A. Decrease.
A. Decrease.
All
Decrease.
agree?
Yes.
As per the equation we write. Okay. Energy equation. Take a break. Take a break or continue.
Yes, please break.
break for 10
I'll
minutes.
give you 5-7 minutes break and then continue. This is very important energy equation actually.
Okay.
Okay. Ready? Okay. Energy equation. For energy equation, it is close to Bernoulli equation, but this equation just we will add losses and any effect from external source like pump, like turbine. This full study